Our next speaker has been with this conference. In fact, he's been doing NYR conferences since he started his PhD. And in his words, every conference is a reminder that he needs to graduate. He's also ranked within the top 10% of saber players in the world. And I always like to heap tons of praise on Dan. I first met him when he was in my class at Columbia, and he's been an integral part of the Learnr team ever since. I can go on and on singing his praises. And normally I'd make him autograph his book when he's on stage. He wrote Pandas for Everyone, but of course it's not an autograph. But luckily we are giving out digital copies, and we're going to start doing the giveaways pretty soon. So with that, I'm very proud and excited to introduce Dan.
All right, so hello everyone. My name is Daniel. I am a PhD student at Virginia Tech. I am currently doing my dissertation topic on data science education and pedagogy, focused on the medical, biomedical, and health sciences. You can kind of look at the GitHub repo for my dissertation, which I realized just now that I forgot to actually link to all the IRB and analysis URLs in there. So it's literally empty right now. Currently, I'm working with Anne Brown, and at Tech, she does a sort of data science consulting service through the libraries, and also has a molecular dynamics simulation lab through the biochem department. Last year, I was one of the interns at RStudio, and I worked on a project called Gradethis, which I will be talking about today. Gradethis is a auto code grader for Learnr interactive documents, and I'm also the author of this book called Pandas for Everyone, which is essentially data analysis, but on the Python side. So how's quarantine going for everyone? We are stuck really in conference calls all the time. To the left here is my sister. She is an ICU nurse at North Shore LIJ out in Long Island, New York. She was very much involved with all of the COVID response in early January. And what I've been doing is I actually just bought a 3D printer back in March and started printing a bunch of PPE things for the mail out to folks. So that's what I've been doing. What I've been doing early in the conference, like essentially 95% of the world, we all played Animal Crossing. I actually scraped the Animal Crossing wiki page and made an R package out of it. So there is now Animal Crossing R data. I started playing a lot of video games since I've been cooped up at home. I've been home since the quarantine for spring break, and mainly I've just been playing a bunch of Beat Saber. I'm a really bad Overwatch player, and I just started my first D&D campaign with a couple of friends. So that's what I've been doing. Since we've been talking about dogs, I updated my slides. Went for a hike a couple of weeks ago with my dog, Hobbes, and so here's some pictures of a dog. So the RStudio Internship, I worked on a project called Gradethis with Barrett Shalerky and Garrett Grolemund. And one of the things I learned was that I am a user of R, not a developer of R. And I wrote a bunch of posts about my experience last year. What was really nice about RStudio was I worked with the education team and Shiny team. And so pretty much every day with the Shiny team, we had an agile, like 15-minute meeting, and with the education team, we essentially met once a week, which was really nice. And you can imagine that when you work for RStudio, everyone's dream is, wait, like they have a Slack channel, let's find out what all the Slack channels are and like join them all. And so that's what I did. Like my first couple of weeks there was joining all the Slack channels. And there was one called Shiny Book, which I thought was super exciting, and I joined it. And my only interaction with Hadley at the time was this. And at RStudio Conf this year, I sort of made up for it. If you haven't seen pictures, I commissioned a bunch of bow ties to give out to the interns and Hadley, and he actually wore it. So I like to think that I sort of redeemed myself there as an intern. So for the Learnr interactive tutorials, it is a system that allows you to put in narrative figures, illustrations, everything that we all know about our Markdown files, but also now have the ability to add in code exercises, which are really like our code chunks that you can execute and change and type and run. It also allows for quiz questions. You can insert videos and interactive Shiny components. So it's really a system to sort of improve learning R. And so how do you make a Learnr tutorial? Just like everything else in R Markdown, you edit the YAML header. So we have a Learnr tutorial as the output, and everything, because of all of the R components that need to be run, it is really a glorified Shiny application. So there's a runtime called Shiny pre-rendered. And all we need to do is put in exercise equals to true, and we now create and Learnr block. What does that look like? So this up here is the code that we just typed, and down here is the output of something of what a Learnr output looks like. You have a block where you can type in code, and you have a button to run, and the output gets executed on the bottom. So in education, so what other cool thing that was being developed? There's a library called Sortable that lets you sort things. This is almost like a Shiny widget, and you can sort things in different orders, and you can see how the resulting vector comes back depending on the order that you sort things. So from the education perspective, you can use something like that to create Parsons problems, which allows you to create questions to teach new learners by reducing the cognitive load, by reducing the actual code that they need to type, like all of the fluff, and just having them to put the code in the right order. So now they're focused on what the concepts are instead of exactly how to write the syntax. And so it looks something like this. If you want like a dplyr example, Sortable allows you to put things in a specific order, and then you can essentially use this as a way to grade and mark code. So what about grading the actual questions? So we can create the questions, but what about feedback? Students need some way to know that like their answer was right or wrong. So the easiest way to doing that is just looking at the result. So this just checks to see if the output of some expression is equal to the solution. So 3 + 3 is 6, which is the same as 2 × 3, right? So that's one example. Another way you can do it is actually look at the static code, so the code directly. So 3 + 3 in our case, even though it equals 6, is not exactly the same as 2 × 3. Likewise, some of the issues, if we want to write an apply statement like this, it is not exactly the same as that. So there's things that we do to make those two things the same. And also, the issue then becomes, okay, what about default parameters like NARM equals false? How do we handle that? These two things should be the same, but if we just look at the code, it's not. So one way we can then do this, if I believe this was last year's talk, NYR talk that Hadley gave, or the year before, he introduced a package called Lobster. And in the Lobster package, you can look at the abstract syntax tree of any R expression. So code is data. So we can run any piece of R code, run it through the AST function, and it'll come out as a visual tree of what the code does. So in this example, we can see log. The first input of log is the exponentiation function, and the input of that is a number 3. So if we change log x exp to 2, we now see log calls exp calls 2. And for more complicated things, we can see log calls log. Inside that version of log, there's a input of 2 and base equals 10. And so we essentially use this as a mechanism to check our code. So that's where Gradethis comes in. It's an auto-grading system that can be used with Learnr grader exercises to check the answer, but also checking the code using the abstract syntax tree. So in Learnr, one of the things is each exercise is independent. I think there are ways now that they're working to expand on that, but the initial conception was just to make life easier. Every new exercise has a clean environment. So that makes it somewhat easier for finding out bugs, but it makes it harder to build up on an existing example. But the nice thing about Gradethis is it actually tries to give formative feedback, not just saying that the answer is wrong, but it'll try to tell you why. And why do we call this Gradethis instead of GradeR? Mainly because during the first week of my internship, someone from UVA actually pushed a package called GradeR to CRAN. So we had to go through an entire system of like, what do we name this thing? So now it's Gradethis, named after test this, and that's that naming convention. Just as a side note, my favorite suggestion was one that was called Gradetron as a thing off of Scantrons, but that was a little bit too much. So what does Gradethis do? It tries to give formative feedback. And so down here, for example, if the question asks to take the square root of the log of the number 2, and the student just puts 2, instead of just saying that the answer is wrong, creating this sentence, I expected of call to square root, where you wrote 2, try again, next time's a charm. Creating that sentence is actually very difficult. And so the whole benefit is to use Gradethis with Learnr to give you a system to grade these code chunks. So there are 3 components. There's first the base chunk, which is essentially what the student sees when they first see the exercise. So that can be empty or pre-filled with blanks, or some existing code and they just need to add the last couple of lines, etc. Then they need a set of checking chunks. So depending on how you want to check your code, whether you use just the result, there is a grade result function. Whether you want to look at the AST, there is a grade code function. And if you are trying to grade like a function, there's a grade conditions, which essentially will do like a unit test system. And you can also add these hint chunks to have hints in the exercise. So what does this look like on the Learnr perspective? First thing we need to do is load up the Gradethis library and then actually say that we are using an exercise checker that's coming from Gradethis called the gradeLearnr function. And this is essentially the hook if you want to write your own grading function for Learnr. And then we have exercise equals true. There is a chunk label, and then this is what the student sees when they first see the question, which is log with 2 blanks. And then if, for example, we want the student to enter log of exp of 3, we have some mechanism to grade this. So we can grade this in 2 ways using grade result. So the way grade result works is, remember, I have these hint chunks, but the check chunk, we put in the grade result function. And then there's a series of passive and fail if conditions that grade result takes. And if we're just looking at the result, we can say, hey, if the result is equal to 3, then pass. If the result is equal to 4, fail, but then give this custom message. Or if the result is just 2, actually put in this other result. And these are 3 different ways that you can specify the passive fail if. If you've noticed this function curly bracket and this tilde notation, if you use the per R package, it is exactly the same mechanism there. You can then also use Gradethis to grade the code. So the difference here is we also now have to provide a solution block because it's checking the solution. So the instructor will put in the solution that they want to check. And then in the check block, they run grade code. And then there's a mechanism to grade the conditions. So if you're trying to actually mark a function, you can pass in a suite of unit tests, and then it'll try to tell you how many of those tests passed or failed. So in here, you would notice that the chunk names actually matter. This chunk label is actually what ties the hints and solution and check code all into one exercise. And also as a factor, because of knitr, all of these chunk labels need to be unique. So to make life a little bit easier, one of the things that I also worked on last year was adding a RStudio add-on that essentially throws in this block with a random sequence for the chunk label, just so you can very quickly create these exercises without coming up with a new name. Because when I work in knitr, I almost never create chunk labels unless I actually need to. So one of the things that I learned last year is being careful with the double equals operator. You can call it an inconsistency, or the documentation is not clear, or a straight up bug. But this was one of the things that I discovered just trying to actually grade some of the code that I was using for an example. And you can see here's 2 pieces of code. I'm using quote, so R is not going to actually execute this command. So it's not going to actually call f of this. But the 2 things you'll need to notice is that these 2 statements that are going to be compared, there is a difference. The last parameter, or the last number or value passed into this function, is actually different. But if is U double equal S, you actually get true. But that's a roundabout way of saying that if you actually want to compare if two things are actually equal, you use the identical function. And this is one of those, being a user of R versus being a developer of R, you have to use more robust functions when you are trying to develop packages. We wrote about this. Essentially, the takeaway is the way quote works. The way quote works is it will take an expression, and if it's longer than 60 characters, it will create a vector 60 character chunks. But when you use double equals on an expression, it only compares the first value. So that's why it comes out to be true, and everything at the end will be ignored. So Learnr versus Gradethis. If you're trying to work with this, this is the one thing to keep in mind. Learnr is responsible for expression capturing, data reporting. If you need to capture how many correct answers a student got, how much time, all of that stuff is captured in the Learnr system. And you essentially have to use that system to build out like something that you would use for like a MOOC, for example, or to grade your own classwork. Gradethis is just responsible for checking the solution and reporting back some kind of statement, whether that is just a simple "you got this right or wrong," or actually that difficult statement of where you got your answer wrong. So Learnr is actually a very complicated piece of software. You essentially need to know all about how knitr works, R Markdown works, and how Shiny works. It is essentially a big capstone project. One of the current RStudio interns this summer, Mistral, he actually wrote a blog post on learning how the Learnr system works. So if you want to learn more about all of these tools, that's a pretty good blog post to start. And I spent most of my summer just understanding how capturing expressions work, and so he's actually learning about this insane project. All of the exercise components are passed into the exercise checker. So this exercise checker, we in Gradethis provide a grade Learnr function, but if you need to do something else, this is where you would put in your own gradeR function or grading function. And everything from Learnr, like those parts in the code chunks, that all gets passed into this exercise checker function. So your exercise checker function needs to be able to take in those components, and then you can do whatever you want with it. How do we deal with pipes? So in Gradethis, we actually go through the process of unpiping any code that is piped. So if you do something like df pipe into dr select column 1, the first thing that we do is we detect if you use pipes and then unpipe all the code before we do the AST checking. So that's why some of these statements seem to be a little wonky when you read them. So one other thing you can use is you can actually use Gradethis as a standalone code checker. So for example, we can library the Gradethis library. Let's say the student passed in the value of 5. We can actually call grade result directly and say, if they got the value of 5, pass. And here's the magic sauce, is that there is actually an argument called Learnr args. It takes a value called last value, and then this is what it's being used internally to check the student result. And then you get a graded object back, a grader graded object back, which is really just a list with a message and whether or not the answer was correct. You can also use this to grade code. So we can quote arbitrary expressions. I'm going to set it to student code and solution code. And then you can also call the grade code function directly. And then the magic sauce here is there is a grader args parameter, which takes a list and takes in those two expressions. And then you get the same grader graded object back, which is just a message and whether or not it is correct. One of the things I learned during the internship is actually how tidy eval works. So in about 2 minutes, I'm going to explain to you how this works. We've seen formulas in ggplot and writing our formulas for models. And we can say tilde x caret 2. And we can actually save this to a variable. It is a formula and has that expression. And what we can actually do is take the second argument of formula and it gives in the actual quoted expression. And and we can do that with anything with the tilde, and that's how the tilde works. And then from tidy eval, we can say, what is the expression? So this x caret 2. And the magic sauce here is we can pass in a data parameter defining what all of those variables in the expression mean. So we can say, in that expression, we're going to set x equals to 5. If we want, we can also provide an environment if it's not provided in data. And then when we eval this expression, it calculates it. And so in actual practice, that little bit of code is actually what we use in Gradethis. And so what I just showed you is exactly that same mechanic. And so this isn't our conference, but Mistral is actually working on the Python port of Gradethis. And so you will be able to do code checking in Python. Right now, you can actually still use the result checking in Python because of Reticulate and how Reticulate works. But we are slowly working on implementing this from the Python world. And so with that, I would say thank you for my talk, coming to this talk. And you can find me here. And the slides are there. And right after this, I will be posting the slides as the PDF. So thanks.
Thank you, Dan. So now we come to our lunch break. We are miraculously ahead of schedule. This has never happened in the past 5 years of the 7 different conferences we have run. We've never been ahead of schedule. We actually thought the digital conference would be further behind than the real in-person one. This is amazing. So we're going to get back on schedule by taking a slightly longer lunch break.